Okay, let's do one more example here. So now we're going to consider a region bound by y equals sine of x plus 2 and the line y equals 2 over the interval between 0 and pi. Now in this case we're just being asked to set up the integral as opposed to actually evaluating it, and we'll see why that's the case in just a minute. So let's go ahead and get this region set up. So we've got our y-axis and our x-axis, and y will have x. Now this region is going to be revolved or rotated around the line x equals -1. So I'm going to go ahead and I'm just going to kind of put that in there too. Now let's think about this curve sine of x plus 2. All that is it's the sine curve that's been rotated, or excuse me, that's been shifted up 2 units. So normally the midline of a sine function is the x-axis. Now it's going to be up here at 2, and the amplitude is 1, so it's going to oscillate between a range of x equals +1 and x equals 3. And we're going to go out to pi, which means that we're just going to kind of get one little hump of the sine curve. So it's going to start here at 2. Halfway through it's going to max out at 3, and then it's going to reach back to its midline 2. So the curve might look something like this. It would then kind of continue on this way or that way on the other side, but we're not interested in that because we're only interested in it bound between the line y equals 2, which we would draw right here, and then this is our curve y equals sine of x plus 2. So here's our region of interest right here. Okay, so we are going to rotate this region about this line. I'm going to go ahead, I'm going to draw our axis of rotation now. So this is our axis of rotation, x equals -1. And here, this is what we'll be revolving around. Now, again, if we wanted to try and do a washer method, it's not going to be pretty. So what I would say is vertical axis of rotation, everything is already in terms of x. Let's try a shell method. So I'm going to draw a cross section here. And I'm going to say that this cross section occurs at some point x. And then we're going to go through and we are going to determine what our characteristics are. So we need 3 things. We need our bounds, we need the height of a shell, and then we need the radius of a shell. All right, so what are the x values over which this region is bound? Well, it looks like the region is bound between 0 and pi. We don't care that it's going to go over to x equals -1 because the region doesn't extend there. The region is just bound between x equals 0 and x equals pi. And then the height of this curve, kind of like the last one we're going to do, is the height of this cross section is going to be the top curve minus the bottom curve, which would be sine of x plus 2, our top curve, minus the curve that bounds the cross section below, which is just y equals 2. Luckily this works out to just end up being sine of x once those 2's cancel out. Now the radius you've got to be careful about here, but remember the radius is, and just kind of keep telling yourself with these problems, the distance from the axis of rotation to the cross section that we have drawn at x. So what is the distance from here to here? Well, it's going to be this distance x plus this distance, which we're just going to always treat as a positive value, which is just 1. So this is x, this is 1. We add these together and we get a radius equal to x plus 1. And there we go. All right, so now we've got all we need to set up our shell method integral. So volume will be equal to the integral from 0 to pi of 2 pi times the radius times the height dx.